Example 2b, we have an equation here, 9y squared minus 7x squared equals 63, and our job is to find the vertices, the foci, and the asymptotes of this hyperbola, and to sketch the graph. Just looking at our equation, we are not in our standard form though, since our equation equals 63. First thing we need to do is to divide both sides by 63. 9y squared over 63 is going to give us y squared over 7. 7x squared over 63 is going to give us x squared over 9 equals 1. Okay, since in our equation the y squared comes first, that tells us that our hyperbola is going to be up and down. And also don't forget that this first number tells us where those vertices are. So this tells us we have vertices at the square root of 7 plus or minus. Well, let's start off with this information and see what else we can do with it. Okay, well, we have vertices at the square root of 7, and again, our hyperbola goes up and down. So our vertices are on the y-axis. The square root of 7 is somewhere between 2 and 3. It is 2.6. Okay, so we'll kind of estimate there. We're at the square root of 7. And negative square root of 7 down here. And since we have to list out this information anyway, I'm just going to make my list over here for the vertices, the foci, and the asymptotes. Okay, well, the vertices, we're on the y-axis, so those points are 0 plus or minus the square root of 7. Then let's look back at our equation. We have this 9 here. This other number, remember, tells us the other dimension of our central rectangle. So our central rectangle goes to 3 on both sides, goes out 3 either way. So go out 3, out 3 over here. And keep in mind those diagonals tell us the asymptotes for our hyperbola. Try to draw in those asymptotes as best as we can. Keep in mind as you're doing this, this really is a sketch. It does not have to be perfect. Look, my scale is definitely not perfect. My x-axis over here, the increments aren't perfect, but that's okay, just a sketch. So this is a good idea for us to get started, and we can actually, since we have the asymptotes drawn in, we can draw in what our hyperbola is going to do. Where we're getting closer and closer to these asymptotes on each side. Big thing that we have to find is where our foci would be. And our focus has to be inside our hyperbola somewhere. So right now I'm just gonna kind of plot a point here. Well, I know where my vertex is. I know the origin. I know the other dimension for my central rectangle. If I can find this hypotenuse, that's going to tell us where our focus is. So we're at the square root of 7 here for our vertex. That's this length of our triangle. We go out to 3. That's the other leg for our right triangle. Pythagorean theorem will tell us our hypotenuse. The square root of 7 squared plus 3 squared equals x squared. Square root of 7 squared is 7 plus 9. 16 equals x squared, and that means x has to be at 4 plus or minus 4. And that works out pretty nicely. So really my focus, instead of where I had it, is really up here. And then down at -4. The foci is 0 plus or minus 4. The last thing we have to figure out is equations for these lines for our asymptotes. And keep in mind that when we are finding an equation of a line, we're looking at y equals mx plus b. B is our y-intercept, and we go through the origin here. M is our slope. If I go from the origin to one end of my box here, I go up the square root of 7 and over 3. This is going to look kind of messy, but up square root of 7 over 3, that's my rise over my run. That's my slope. The plus or minus, the positive square root of 7 over 3x gives me this line. Negative square root of 7 over 3x gives me this line. All right, so that's everything we need for our problem. We got our graph, we got our vertices, we got our foci, and our asymptotes.